Welcome back, everybody. Welcome to day 2 of the security stream for the GSE Virtual Conference 2023. I know a few of you joined Mark's kickoff session this morning, so yeah, very busy day yesterday. And I think you heard the numbers, 666 attended GSE yesterday. That's not just for security, by the way. It would have been nice if it was, but there's some really good numbers. So as I said yesterday, in closing the security stream for the day, we've got a full agenda here in security today, so I hope you can join us for the day. But up first, we have Gwydion Tudor from, and I'll let him introduce himself in a moment, but he's from Hursley, from IBM Hursley, and works in MQ development. And Gwydion's been with us a few times, haven't you, Gwydion, for presenting on the GSE security stream, giving us various updates. So it's great pleasure to welcome you back. So without further ado, Gwydion, over to you. Thank you.
Thank you very much, Jamie. Thanks for the introduction. So as you said, my name is Gwydion Tudor. I work in the IBM MQ development team based at IBM Hursley. Today I'm at home. I didn't think I should fight the traffic to get in by 9 o'clock, so this is much less stressful. So this session is going to be on controlling access to your MQ system. And essentially what we're going to look at is how to identify and authorize, authenticate and authorize connections that are coming in to your MQ system. So essentially this is the scenario. You have a queue manager, of course, if you're doing any MQ messaging. The queue manager is that blue cylinder on the right-hand side of your slide. And if you have any applications that want to do messaging, then of course they're going to need to connect into that queue manager. The applications might be connecting in remotely over the network, or they might be running locally on the same system as the queue manager and connecting in without using the network. So essentially that's using some type of inter-process communication on the machine. Either way, you're going to need to somehow authenticate the connections coming into your queue manager. And once the applications are connected, you also want to make sure that the application can only do the operations that it should be doing. So for example, an application connecting into MQ might be a messaging application, might be one of your business messaging applications. So it needs to be able to put and get messages to the queues that have been defined for that application. But also an application connecting into the queue manager might be one that's designed to administer the system. For example, if you're using MQ Explorer, then that's exactly what the MQ Explorer is. It's just an application that connects into MQ and then lets you issue commands to the queue manager that you're connected to. Two kind of different types of applications, but still from MQ's perspective, they're just applications, but they need different authorities. Or the user IDs that those applications run as need different authorities. One needs access to queues to do your business messaging. Another needs access to be able to issue certain commands to administer your system. You probably don't want your business application being able to issue commands to order the queue manager, for example. So that's why we need authorization for what the applications are able to do. And of course, the other thing that we need to do is to keep the bad guys out. So we only want applications that are actually authorized to connect to be able to do so. So that's essentially the goal of setting up security in MQ. We need to only let the people that we want into the queue manager, and then once they are connected, we want to make sure that they can only do the things that they really should be able to do. So that's our goal, and let's start off by looking at identities. And what I mean by identities is that any application, or actually queue manager connecting into a queue manager, because we can have connections between an application and a queue manager, or one queue manager to another in MQ. So a connection that comes into a queue manager can be from either an application or a queue manager. Either way, it's a connection, and some form of authentication needs to happen for that connection. So an identity is something that the queue manager or application that's connecting into MQ is asserting as some form of identity that will identify to the queue manager that is connecting to. And once we can identify who is connecting into the queue manager, then that later on will give us a way to authorize what that application is able to do. Or I should have said connection, what that connection is able to do, because there might be an application or a queue manager that's connecting it. Now, there are several different identities that applications or queue managers connecting into the MQ are able to provide. And here they are on this slide. So if we start off towards the right-hand side of the slide with IP address and host name. So if an application is connecting in over the network, then one of the bits of information the queue manager is connecting to gets is the IP address or the host name of the machine that's connecting from. Obviously, this doesn't apply to locally bound applications that are running on the same system as the queue manager. Now, of course, you might say that this isn't very strong because IP addresses are not unique to an application, not unique to the system even. And also there's ways of spoofing IP addresses. So you wouldn't want to rely on this being a way of getting strong authentication for your connections into MQ, but nevertheless, it is a piece of information that is presented to the queue manager that can be used to some degree at least, give an identity to the connection that is coming into the queue manager. Something that is a lot better, you might say, is a certificate. If the connection, again, we're talking about applications or queue managers that are connecting in over the network rather than being locally bound. Now, if that connection is using TLS, then of course, you're probably familiar with TLS. You'll know that there is a certificate that gets exchanged. There are certificates that get exchanged between the client and the server during the TLS handshake. And if the client, and in this case, in MQ terminology, that's going to be either a connecting application, so an MQ client, or it could be a queue manager that's connecting to another. If that client sends a certificate to the queue manager as part of the TLS handshake, then that is a bit of information that can be used to identify the application or queue manager that is connecting. The other bits of information that the queue manager gets when an application connects into the destination queue manager is a user ID. So the application will be running on a system somewhere in your network, and it will be running under a user ID on that system where it's running. And that user ID that it's running under on the system where the application is running gets sent over to the queue manager as part of the initial data exchange that happens between the application and the queue manager. So that is a piece of information that the queue manager gets to know. You, again, might not want to trust it because you don't know how that user ID has been authenticated, if at all, on the source system. But nevertheless, it is something that the queue manager gets to know about the application. Now, more recently, and by more recently, I mean MQ version 8, which has been out for many years by now, but it is more recently in the scope of the 25 years or so that MQ has been around for. We added the ability for applications to programmatically specify a user ID and also a password when they connect to the queue manager. And the way that they do that is by specifying the user ID and the password in a data structure called the MQ CSP. And they specify that structure when they issue the MQ connect call to connect to the queue manager. So that's because it includes a password, that is going to be a bit more trustworthy than just going with the user ID that the client is running under on the operating system where the application is running. But anyway, those are the options that we have for how to identify the application that is connecting into the queue manager. Now, things are slightly different when you have a queue manager connecting into a queue manager. Not all of those things on the previous slides applies in this case. The IP address and the host name of the source queue manager does apply, as does the TLS certificate, if the connection is using TLS. But instead of the user ID or the user ID and the password the application can specify, instead we get to find out, or the target queue manager gets to find out the name of the queue manager that is trying to connect to it. So those are the bits of information that the receiving queue manager gets to find out about the connecting queue manager, and we'll see in a few slides' time how we can make a decision based on those bits of information about whether we want to allow a connection or not. Okay, so as I said, those are the bits of information that we have that form the identity of the connecting application or the connecting queue manager. We want to decide now whether to trust that information or not, and ultimately whether to allow the connection in or not. And the way that we do that is by authentication. Obviously, we don't want to just trust that a user ID that the client says that is running under on the source operating system, for example, is valid. It doesn't come with a password or anything like that to actually prove that that user ID is what it is, for example. So if I have an application running on my laptop here under the user ID Gwydion and I connect to a queue manager on a different system, yes, my application will tell that queue manager that it's running under the user ID Gwydion, but it won't send any information to actually prove that. So we do want to put some rules in place so that we require some information to essentially trust what we've been given by the client, and this is what authentication is doing essentially. And MQ provides several mechanisms to let you check the identity of the applications or the queue manager that's connecting in to MQ. I'm going to look at some of those options that you have now. As I think I've already mentioned a few times, there are different options, and the ones that you have are slightly different based on whether you have an application connecting into your queue manager or another queue manager connecting into your queue manager. But I'll point that out as we go along. So here are the options we have. So first up, we have TLS. Now, you're probably quite familiar with TLS already. TLS is often used to encrypt connections between two endpoints, and it does that very well. But of course, because there are also certificates being exchanged during the TLS handshake, it also gives you a way to authenticate connections. So by default, the server, and in this case, that would be the queue manager that's being connected to, the queue manager will supply a certificate to the client that is connecting to it. And optionally, the client can also supply a certificate to the queue manager. Now you can configure on your channel definition on the receiving queue manager whether that should actually be a requirement or not, whether you want to require that the client or the queue manager that's connecting into your queue manager should have to send a TLS certificate as part of the TLS handshake. And that's how you can use TLS to authenticate your client applications or queue managers that are connecting into your queue manager. And of course, as you probably know already, what we do when we receive a certificate, and this is true for both ends of the connection really, is that we have to establish whether we trust the certificate. And often that will be done because the certificate that you receive will have been signed by a certificate authority, and the CA certificate will have been imported into your queue manager's key store, and that's how the queue manager can verify that that certificate has been presented with is trusted. So at that point, it knows that the application or queue manager that's connecting in supplied a certificate that is valid and trusted, and it should allow that connection to come in, subject to further rules about who exactly we allow in that I'm going to get on in a few slides' time. Now, you also have other options to specify who is allowed or not to come into your queue manager based on all those various different forms of identity that I talked about earlier. And the way that you do this in MQ is by using what's known as channel authentication rules. And these are things that you define on the queue manager with a set channel auth command. And they're essentially filters that will let you block or allow connections based on the attributes or the identities that I talked about earlier for that connection, whether it's coming from an application or a queue manager. So you can set channel authentication rules are to block connections that have certain attributes or allow connections with certain attributes. And the different types of filters they all correlate with the identities that I talked about earlier. So you can, for example, block connections from a certain IP address or a host name, or block connections from a certain remote queue manager name, block connections that are coming in with a administrator user ID, for example, or you can block or allow connections that come in where a TLS certificate has been sent based on the distinguished name of the certificate. So that's quite a powerful rule that links with what I was talking about on the other slides about when you have a TLS handshake and using that for authentication. The fact that the certificate is trusted doesn't mean that you necessarily want to allow that application to connect. You might want to only allow a certain application with a certain certificate to connect. And it might be the distinguished name of the certificate itself that you want to filter on to decide whether you want to allow the connection to come in or not. And this channel authentication rules, that is one of the mechanisms that allow you to do that. Another one potentially is that you can use security exits as well. And security exits are essentially ways for you to configure the MQ security checking yourself by either writing some code yourself to implement whatever security checks that you want, or maybe buy a third-party exit because there are some available. And they conform to a specific API. They get given various bits of information about the connection that's coming into MQ when the connection arrives on the channel. And then they can decide what to do with that connection, whether to allow it or not. And you can implement pretty much whatever you want. You can have exchange of data between a pair of exits, for example, if you want to add additional checks. Or you could, for example, implement something similar to multi-factor authentication for MQ if you wanted to, using a security exit. So because it's an entirely blank slate, that as long as you're prepared to write it yourself and maintain it yourself, you can use to add additional capabilities to MQ. Now, everything I've talked about so far applies to both applications and queue managers connecting into a queue manager. Now, something that applies to only applications that connecting to your queue manager is connection authentication. Now, if you remember, a few slides ago, I was talking about the different identities that applications can assert. And one of the more recent enhancements is the way for applications to send a user ID and a password to the queue manager when they connect. And the way that we configure the queue manager to check the user ID and the password is to use connection authentication. Now, this is a bit of configuration we have in the queue manager that specifies whether and how the queue manager should check that user ID and the password that's specified by the client. You could actually tell the queue manager not to bother checking the user ID and password at all, or you can tell it that every user ID, every application connecting must specify user ID and a password. And also the user ID and password that is specified can be validated against several different types of repositories. Or rather, you have a choice to pick one of the different types of repositories in your queue manager configuration. So we can verify against the local operating system, and that'll be on ZOS, that'll be what's in RACF, or on distributed systems, it'll be whatever the whatever's defined as the user ID and the password combination in the local operating system. If you have a centralized LDAP repository, then MQ can also call out to the LDAP server to check that the user ID and password supplied by the application is valid. You also have the option on Unix systems of using or checking against PAM modules. So this is a feature in Unix that lets you add additional pluggable modules, essentially, to add additional authentication capabilities to your Unix system. And of course, similar to what I was talking about on the last slide, you also have security exits that come into play here, because security exit does get the MQ-CSP data as part of the information that it gets about the incoming connection when it gets called. So you could use a security exit as well to do whichever processing you want on the user ID and password that's sent by the application, and then block or allow the connection based on whichever checks that you want to perform in your security exits. So I've introduced a few concepts there. Hopefully I haven't confused you too much, but it might make things a little bit clearer if I show you this chart, which lists all the options that are specified so far, and also shows you in which order the queue manager will go through all the different checks for a application that is connecting in. Now, if you look on the far left to begin with, this is the flow for a application that is connecting in as a client. So an application that's running remotely somewhere and connecting in over the network to your queue manager. And these are the sequence of checks that the queue manager will go through to authenticate that connection. So first of all, it's going to look at the channel authentication rules, and it will specifically look at the block address rules to check if the IP address and the host name that the connection is coming from has been specifically blocked. And if it has, then the connection won't get any further than that. And I think actually you'll get a return code similar to host not available rather than not authorized at this point. It will just stop the connection. If the connection gets past this point, then it might be that the channel has been configured to use TLS. And this is the point where the TLS handshake happens and the certificates get exchanged. And of course, the connection can only proceed if we trust the certificate that's been sent from the queue manager to the client and from the client to the queue manager if that has been configured. And the next step is to look at the channel authentication rules, the mapping rules. Now we'll look a little bit more in more detail at what the mapping means a bit later on. But essentially, these are the rules that you set up to allow connections from specific places, and to say what you want to do with those connections in terms of which user ID you want to map them to. So it could be, for example, that having completed the TLS handshake in the previous step, that you have a rule which allows a connection to proceed if the certificate that's been sent by the client has a certain distinguished name. And this is where we check that the distinguished name is what we expect it to be and allow the connection to proceed if it's correct. That's what we expect. So next up is the security exit. This is when the security exit gets called and is able to do whichever processing it wants, block or allow the connection, and also decide the user ID that will eventually get assigned to that connection. After that is the connection authentication check. So that's checking the user ID and password that is sent by the client in the MQ-CSP structure. And assuming that user ID and password combination is valid and that the application did meet the requirements completed in the queue manager. For example, if the queue manager has been set to require a user ID and password to be sent, the application actually did send one, and a valid one as well. After that, now that we know the user ID that we're going to use for this connection, finally we look at the channel authentication rules to see if it's been configured specifically to block certain user IDs from connecting. And if it hasn't, then we have passed all the authentication checks in the queue manager, and we're on to now using the user ID that we have assigned to this connection for authorization checks in the queue manager, which will be whether the application is allowed to actually connect and open queues and so on. Now, most of those steps don't actually apply to applications that are running locally, because they mostly all apply to applications that are connecting in over the network. They don't make sense to do those checks for applications that are locally bound. So local applications, which are not actually clients, that wording is slightly misleading in the slide, I'm afraid, sorry. So locally bound applications will go to the connection authentication. So if they do specify user ID and the password in the MQ-CSP structure, then that will get checked by the queue manager. But that's all pretty much. We then skip straight to having authenticated that connection and then using that user ID to authorize or 4 authorization checks for whichever operations that application wants to do. Now, everything I've talked about so far can be configured in a fairly granular manner on the channels that you have defined in the queue manager. Now, you might have a need for different levels of checks based on different connections. That might be all sorts of things. It might be that you trust your internal connections more than your external connections, or it might be that you want different levels of checking for connections that are to do with administration compared to connections from your business applications, for example. So you've got many options to do this, or at least MQ gives you the ability, rather, to configure your security in a fairly granular manner. So you might wish to do something like we have described in this diagram, or it might be that you really don't want to trust anyone and that you wish to apply fairly strict security to all connections that come into your queue manager, and that will be more in keeping with the zero trust model that is getting more popular these days. Either way, whatever you choose to do, you do have the options provided to you by MQ to be able to configure that. And the way that you do that using the facilities that I've introduced to you in the last few slides is that you can configure most of what I've talked about on a per channel basis. So security exits, for example, you can apply those on a per channel basis. You can put in the channel definition which security exit should be called when a new connection comes into this channel. With TLS as well, you can set in the channel definition whether clients should be required to send a certificate or not when they connect to the channel. And you can also set on the channel definition whether, which distinguished names should be allowed to connect to that channel when TLS is being used to establish the connection. You can do that on the channel definition. You can also do exactly the same thing in channel authentication rules as well, and channel authentication is a more flexible way of doing it. Channel authentication rules as well can be configured to be specific to a certain channel, or actually set of channels, because you can use wildcards in the names of the channel of the channels that a specific channel authentication rule will apply to. We do have a question it's just appeared in the chat about, can you use multi-factor authentication for external user connections like MQ Explorer? There is no specific support in MQ at the moment for multi-factor authentication. MQ Explorer actually is a case that we point out where it might not work very well, because MQ Explorer actually creates several connections into the queue manager if you do certain operations. So when you connect to a queue manager using MQ Explorer, you obviously got one connection happening there. If you want to browse messages from MQ Explorer, there's actually a separate connection being made from the Explorer to your queue manager at that point. Now, that is a problem, because with MFA, you can't reuse the credentials that you originally used to connect into the queue manager. So that's a specific problem with the applications that work like MQ Explorer. Otherwise, if you're not using MQ Explorer, you might be able to, but only as long as the user ID and password that MQ is checking if somehow has MFA supported by whichever subsystem is being used to check the user ID and password. So what I mean by that is, if you have RACF set up with multi-factor authentication, and it gives you a one-time pass ticket once you've authenticated in using your various different factors, then you can use that to log in using MQ. MQ will just pass in the password and the pass ticket that's been given by you straight to RACF, and RACF can choose whether to accept it or not. So sorry, that was a rather long question, rather long answer to your question. The short answer is not really. There's no specific support in MQ. Okay, so as I was saying, granular controls, you can set this all up based on the channel the connections are coming in, which lets you have more or less checking based on the channels that connections arriving to. It's the same with connection authentication. When we're dealing with applications that specify user ID and the password when they connect into MQ. So there's a field in the connection authentication definition called check clients, and this is where you can specify, does an application have to specify user ID and a password or not? So it can be optional or it can be required, and you're able to set in the channel authentication configuration one value for the entire queue manager, but you can override that to be more strict using channel authentication rules. So that's how you can have granular controls for your connection authentication. That's whether user ID and a password from the application is required or not for connections into a specific channel. So at this point, we have authenticated users that are connecting into your queue manager. So we believe that we trust the connection, and we have some form of identifying that connection. Now, the next step is to apply authorization checks to that that connection. Now, this is checking whether that connection is allowed to do certain things, and it might be whether they're allowed to actually connect at all to the queue manager, and also whether they're allowed to open a queue to put messages or get messages, or access any of the other resources that we have in MQ as well. Now, this is controlled by granting access to a specific user to a specific MQ resource. So you would grant the user Gwydion, for example, access to put messages to a queue. And that would let me then, or an application running under my user ID, be able to open a queue with the option specified at open time to be able to put messages to the queue. Now, of course, you probably don't want to be dealing with granting authorities to specific users. If you have a lot of users, it's more convenient for you to use groups. So you might want to grant access to a MQ administrators group, for example, to be able to issue the various commands that you need to be able to administer MQ. And then all the users in that group will get access to be able to do those things. But as far as MQ is concerned, it's actually the user ID that it works on when it does the authorization checks. Now, this is something that is at a high level the same across MQ, regardless of which platform they are running on, but the implementation details here do differ between distributed and ZOS systems. So on distributed, you issue commands, you issue MQ commands essentially to add authority records to grant access for you to users to access certain MQ resources. On ZOS, what the queue manager does is to just call into RACF to check whether a user ID has access to a specific profile, and that profile correlates to the name and type of a certain MQ resource, like a queue, for example. It gives you a lot of flexibility. It does achieve pretty much the same thing across all the platforms that MQ runs on, but the exact details of how you do this is slightly different based on the platform. I'm not going to go into the details. That's all in the documentation. The other important thing to say here is that if a user hasn't been granted specific authority to access a resource in MQ, then it's not allowed to. So the default in MQ is that a user, we're talking about a normal user here rather than some kind of privileged user, such as MQM, for example, distributed. A normal user doesn't have access to do anything unless it's actually been granted to. That's the default. So we were talking about identities earlier, and there's various ways of establishing an identity for an application. And I've just talked about granting authorization, which is our end goal really, to certain users or user IDs to be able to do things in MQ. We might need to map from that identity that the application is connected in as to a certain user ID that we can grant access to. And that's especially true if we're using information such as the IP address or the host name of where the application is running to do our authentication, or more reliably, if we're using the distinguished name of the TLS certificate that we've been presented by the application to do the authentication. So we need a way to map from, for example, a distinguished name in a TLS certificate to a user ID for that connection, so that we can grant access, grant authority to that user ID, so the application can actually do things once it's connected. And so we're going to look at modifying identities in MQ now. Now, I've already introduced one of the ways. Well, actually, I've introduced both ways of doing this already. So the first way is your channel authentication rules. Now, I introduced them earlier as ways of blocking or filtering connections. And that's true, they do that. So you can set up rules which specifically block connections, like blocking connections from a specific IP address or a range of IP addresses. But the opposite rules that you have are mapping rules, and these are the ones that allow connections in based on a certain bit of information that's been specified, that's been given to the queue manager during the connection. So we have address map rules, for example, which essentially tell the queue manager, if you see a connection coming in from this address, then map it to this user ID and allow the connection to go in. The SSL peer map one is probably more useful, so you might be able to guess what this does. If the connection is using TLS, then it's this SSL peer map rule that lets you specify that a certificate with a certain distinguished name that is presented by the client is accepted and then gets mapped to a certain user ID. And that's the user ID that will then be used for the duration of the connection. So that's one way of, for TLS connections that come into queue manager, mapping the digital certificate to a certain user ID. The other way would be to use a security exit. That would allow you to have fewer channel authentication rules, essentially. So that would be the benefit of doing that at the cost of actually having to write and maintain some code yourself. Some terminology on the slide that I haven't introduced yet is the MCA user. Now that is essentially the user ID that the channel is going to run under. So setting the MCA user is what we do in the channel authentication mapping rules. It's also what the security exit does when it runs and it allows a connection through. The MCA user is the user ID that's going to be used by the channel for the lifetime of this connection, and it's what all the authorization checks are going to be done against when the connection tries to do things like opening queues in order to put and get messages. Now, all those things that I've talked about so far on this slide are valid for connections both from applications and queue manager to queue manager connections. Connection authentication, of course, is the one that is only valid for connections from an application to a queue manager. And there is a parameter in the connection authentication definition on the queue manager called adopt context. Now, what that does is to tell the queue manager whether it should adopt the user ID that is specified by the application in the MQ structure. So that's the user ID with the accompanying password that's specifically provided by the application on the MQ Connect score when it connects to the queue manager. Whether that should be adopted for the duration of the connection. So that will then get used as the MCA user if adopt context is set to true. Now, as I was saying earlier, when we were talking about the ways to authenticate and block and allow connection into your queue manager, it's granular. So once again, you can set these rules up based on the channel that the connection comes into. So you can have different rules based on different channels in your MQ configuration, and also different rules based on what method is used by the application to assert its identity. So whether it's a certificate that's being provided or a user ID and a password. Now, obviously, there are many different options that I've just provided you with, and that can be a little bit confusing. Hopefully, this slide is a little bit wordy, but not particularly interesting to look at right now. Maybe you could save this away, because it is quite a useful slide, because it shows you the order in which all these things are applied and which user ID will get adopted for use by that channel and essentially used for all the authorization checks for the lifetime of the channel, based on what information is provided by the client and what rules you have set up on your queue manager. So these are the rules in order of priority. So first of all, if we don't have anything else set up and an application connects over the network to your queue manager, given that the user ID that application runs under on the client machine is flowed to the queue manager, that will be used unless anything else overrides it. Now, you probably don't want that, because you don't know how that user ID has been authenticated, if at all, on the remote machine. So it's best to have something else set up that is stronger authentication than that. Now, the next step is there is a parameter called MCA user on your channel definition on the receiving queue manager. You can set that to the user ID that you want the channel to run under. Or you can also set it up to something that you know isn't going to work, some rubbish user ID, and at that point, you will be able to find out if it's being overridden or not by any of the following rules. Now, those are, next in the list is the adopt context field of the connection authentication definition. If that's set to yes, and the application sends a user ID and a password that are valid, then it's that user ID and the password that is going to be used for the lifetime of that connection, unless it's overridden by the MCA user in the channel authentication rule. So these are the channel authentication mapping rules that will say take a distinguished name from a certificate that's been received and map it to a certain user ID. And finally, if you have a security exit, which is actually not particularly common, so usually we would stop on that last but one list on the table. But if you have a security exit in place, then that does get the last say, the final say on which user ID is going to be used for this connection from an application. So save that slide away, because it might be useful for setting up your configuration at some point. Things are slightly different when the connection is coming in from a different queue manager, because of course the information that gets provided is different. There's no user ID and a password for connection authentication, for example. That concept doesn't exist. Instead, if nothing else overrides it, then, and this is a connection to a distributed queue manager now, then it's possible the MQM user gets used. So you really do want to have something set in place to override that. So you have some rules in place, usually a channel authentication rule, to set a MCA user that you would like this channel to run under when it starts up for a connection from a specific queue manager. I think that's what we say on this slide. Do put something in place to secure your connections. This is specifically talking about a connection that is between a queue manager and another queue manager, but of course you really do need to put something in place to configure the authentication for channels that are coming in from applications as well. But specifically talking about what can go wrong if you don't set any rules in place for connections between different queue managers? You could end up, if you don't put anything in place, with a connection running under the user ID MQM, which can do absolutely anything, or pretty much anything, which might let somebody issue admin commands to your queue manager in some certain cases when you don't want them to. So that's why it's important to have things set up correctly. There are additional options on a channel definition that will give you more options or complicate things further, depending on how you look at it. So put-out is one of them that we have listed on this slide. It's short for put authority. So in this case, one of the options that we have for put-out is context. So what the receiving channel initiator does, or receiving queue manager, is to look at the user ID that's in the message and use that for the authorization checks when a message gets put on, say, an admin queue to issue a message. So this is the case when setting put out on the channel might be useful. I'm not going to go into great detail about this. There are several different values for put out. They're all documented in the MQ documentation online. I have so far said that it's one single user ID that gets checked when a connection comes into a queue manager over a channel. That's not strictly true either, because on ZOS it can be up to 2 user IDs that get checked, with the other one usually being the channel initiator user ID, as well as the one that we get from the application or the connection authentication or channel authentication blocks. Again, I'm not going to go into any more details. It is documented. We actually have a table in the MQ documentation that lists exactly which user IDs are going to get checked based on whether it's 1 or 2 user IDs that get checked and what your put-out setting is for the channel. So I'll leave that as an exercise for you to go looking at this in more detail. But the message here is that do have something set up, and we do have a lot of options available for you to set it up in exactly the way that you want to. Finally, I'll look at message validation briefly, because so far we have just talked about authenticating connections that come into your queue manager. So locking or accepting connections via a channel, usually, into a queue manager, and then authorizing what those connections can do afterwards to make sure that they can only access the resources that they really should have access to. But you also, of course, have messages flowing into your queue manager, and those messages might be coming from, or they will be coming from remote queue managers. They might be coming from queue managers that you don't even know. You might be a business partner, and you might want to be able to validate that the contents of that message is what you expect it to be. That is, that it hasn't been changed since it was sent, and that it was sent by who you think it was sent from. And there is a optional component of MQ called Advanced Message Security that can provide this. Now, Advanced Message Security, or AMS as it's called for short, can do this validating of messages. It can also encrypt messages. It's got different modes they will run under. One of them is to encrypt messages so that they can't be read by anyone apart from the intended recipient. The mode that we're looking at here is called integrity. And what happens is that when a message is sent by a sending application, it gets put onto a queue manager somewhere in your MQ network by an application. The message gets signed by AMS. There's a digital signature, a hash essentially of the message, that also gets encrypted using the private key of the sender. And that message flows through your network until it's eventually got by the application that it was destined for. And that application, or AMS of that application, can then look at the signature of that message and verify that that message, first of all, hasn't been changed while it was in transit, and also because it has the public key of the sender. It's able to verify that the sign, the signature of the message was actually encrypted by the private key of the person that we thought was sending us the message. So we verify both that it hasn't changed and also that it came from who we think the message was meant to have come from. If a message doesn't pass those checks, then it just gets rejected by AMS. And this all happens transparently to the application. So it's actually AMS that is doing the signing and the checking of the messages. The application don't know that any of that is happening. It's just happening under the covers as far as they're concerned. So finally, onto our conclusion. We have looked at authentication connections in MQ and then authorizing what this connection should be able to do. You should have this set up on your queue managers one way or another to ensure that you don't have people connecting into queue managers that you don't want. First of all, because you've got important data presumably on your message queues. You don't want people to be able to access that if they shouldn't be accessing that, and also to protect your MQ configuration. You don't want people issuing commands to change your MQ configuration unless they are actually admins in your organization. So some things to consider when you're doing this is when you're setting up your authentication, how are you going to authenticate that connection? So which bits of information sent by the client is going to be usable and reliable to identify that connection so that you can properly authenticate whether that connection should be allowed into your queue manager or not. Then how are you going to map that identity that you've just authenticated onto a user or user ID that you will be able to use to grant authority to access certain objects so that your application is able to do the things that it needs without doing the things that it shouldn't be doing. And finally, that last step of which authorities exactly does that application need. You need to grant it the ability to do things that it should be doing without granting it the ability to do any more than that. The final slide is a little bit scary, just to highlight that security actually is quite a wide-ranging topic, as I'm sure that you're aware. What we've covered today is the bits inside the red box on the top, as well as a little bit about using advanced message security for checking the integrity of messages. Now, there are obviously many more things to consider if you look at your MQ security setup overall. On top of what we already talked about, there's possibly using AMS to encrypt your messages as well to make sure that it's only the intended recipients of the messages that are able to read them. There's also monitoring your environment so that you get early warning of anything untoward happening in your MQ environment. And there are various ways of doing that in MQ. For example, the queue manager will output event messages when the configuration changes. We also write various things to error logs. What we've got on the slide here is actually fairly specific to the distributed queue manager, but there are same concepts that apply to the ZOS queue manager as well. It also writes information out to the job log with messages whenever anything important happens. It's RAGF that will be auditing information on ZOS whenever something happens in MQ that causes it to call out to RAGF to check whether a user ID is permitted to access a certain resource. So the same concept, just again, between the different platforms, there are some implementation differences. And also the other thing that we haven't talked about is that your connections between your applications and your queue manager, or even between a queue manager and another queue manager, might be going between different networks. And on the network boundaries, the connection might well be passing through a DMZ. That's quite common. And you'll probably have some sort of proxy running there. There might be various proxies even in the way between a connection between two endpoints, two MQ endpoints. And one of the proxies that you can use if you're connecting two MQ endpoints together is MQ Internet Pass-Through, or MQIPT for short, we have on the diagram there. And that's a proxy that essentially understands the MQ protocol, and it can be used, and it is often used as a entry and exit point for your MQ traffic coming in and out of your organization when it has to go through a DMZ. especially if you need to terminate the TLS connection, for example, in DMZ, which is seems to be a very common requirement that companies have. So that is all I had to say on MQ authentication and authorization today. We are constantly trying to improve the security features that we have in MQ. So if you do have any suggestions for enhancements that we can make, then we'll be happy to hear them. You can let us know by either raising an AHA idea, which is the new name for the RFE process that you used to be able to use to send us requests for enhancements, or you can contact me directly. I think my email address is visible from the conference agenda. And specifically, as I've been talking about authentication today in MQ, if there's any authentication security systems that you think that MQ should integrate with, then let us know that. And obviously I can't promise anything, but we'll take it into consideration when we design the next enhancements to MQ in this area. So thank you very much for listening, and please submit your feedback, and thank you. Thanks.
Thanks, Gideon. Wow. So first of all, I'm minding my manners here. Any questions from the audience? You can also unmute your line, or you can post a question for Gideon in the chat. You want to? Very quiet there. I think you dazzled them, Gideon, with that last slide with the complex network.
It's done.
Yeah. So did I hear you correctly at the beginning saying that MQ's 25 years old now?
I think we have passed 25 years. Yes.
Wow. Do you know, I can remember I was working in security administration time when it first came about, and now you say it, yeah, it was around about 1998, 1999, I want to say. And I can remember the MQ like this new team, and that was suddenly just sort of in the where I was working, and this team like magically appeared, and then they walked up to my desk and say, "We've got this new product called MQ, and we need you to set up a load of racket stuff for it." It's like, oh god. So God, time flies, doesn't it? Wow.
Yes.
Yes, indeed. So yes, folks. So thank you, Gideon, so much for coming to present us once again. I'm sure you'll be back at when we have the in-person conference, because I know that. So the MQ, by the way, there's a dedicated stream for that, the conference, and Gideon features heavily in that. So I'm sure we'll see you at the in-person conference in late October this year.
I haven't advertised it so far, but we do have some MQ sessions in the conference tomorrow morning. Excellent.
Very good. And I'm just putting in the link in the chat to the feedback for Gideon session. So if you could do that, so that's session 7F, just a quick recap on feedback. So it's important for Gideon, it's important for us at GSE to help us improve the conference, and also for you, if you're collecting CPD points and you want that certificate, you can download from my GSE to support an education portfolio or credentials, things that you might have where you need to provide that evidence. So please do that. So, and another FYI, I did say this yesterday, we have just announced our next security working group meeting. That's going to be on Thursday, the 29th of June. That's going to be a hybrid affair. So we're just trying to sort out a venue at the moment somewhere in the UK, but you'll also be able to join in on Zoom if you're not able to make it. And we are looking for presenters as well. So if you're interested in a slot for that, then do drop me an email. So once again, big thank you, Gideon, for taking us through that. Just there's so many options now for security for MQ, isn't there? It's yeah, it almost feels like a full-time job. As you know, but if you can do security properly, then that's what it takes. Yeah. So up next, so we've got a 30-minute break for until 10:30, and then in the security stream we have our next session which is around the ransomware protection and virtual tape. So that's with Tim Redding from Luminix. So I hope you can join us for that. But as I say, there are other sessions running. So have a look around the agenda if that's something you're not really interested in, and have a look around the agenda. Other things, all mainframe related, that you can tune into. So thank you once again, everybody, and we'll see you in the next session. See you soon, Gideon. Thank you.
Thank
Bye.
you. Bye.